Hello everyone, in today's video we're doing the electrical package on the shed. We're going to be adding a handful of outlets and lights so this shed is ready to become the next backyard office. I start by laying out where my outlets, switches, and lights are going to go. Wherever I need an outlet, I put a mark on the wall 18 inches from the floor. I draw a circle with two lines in the center to indicate that this is a location for an outlet. For these type of projects, I like to use a plastic nail-on electrical box. They are one of the cheapest options and very easy to install with a hammer. As far as switches, I locate them 48 inches from the bottom. A switch is indicated by the S1 symbol, which means a single pole switch. In this case, we're gonna have two switches, a single pole for the inside and a single pole for the outside lights. Whenever installing an electrical box next to a doorway or even a window, do not install right away. If you install it right on the stud, it's going to interfere with the trim that's about to be installed around the doors. What you need to do is first install a couple scrap pieces of 2x4 on the stud. That will move the switches out far enough that you can install the trim work and not interfere with them. Once everything is laid out, all the boxes are nailed, I start to plan out how I'm gonna route the wires. The easiest approach is that you start at one point and you hop from electrical box to electrical box. We call that the in and out approach. And also make sure that you have a path laid out for the lights. In this case, we are having pocket lights on the ceiling. They do not need electrical box. They're gonna have direct wires to the light fixture. Then it's time to start drilling the holes. I drill a 1-inch hole to the outside of the shed. That's gonna be so the wires can get through with a connector. And I had a 3/4 inch paddle bit drilling the holes on the inside. Make sure when you're drilling the holes, you drill right in the center of the walls. That is so you minimize the chance of screwing in the wires when installing the sheetrock. And by any chance, if you cannot drill on the center of the wall, I recommend installing some nail plates so you don't hit the wires with the screws. Nail plates are pretty cheap and you can install them even if you drilled on the center of the studs. The same goes for running the wire up the wall and across the rafters. When drilling on the rafters, make sure that you drill on the center because in here, not only you have the sheetrock being installed on the ceiling, you also have nails from the shingles on the roof that can hit the wires if they drill too close to the roof. And lastly, it's drilling out for the outside lights. I'm having two lights, one on each side of the door. Now it's time to run the Romex wire. Do not just pull the wire right out of the coil. That's gonna make a tangled mess. I recommend you step on it and you walk it out. That way it's much easier to pull the wire through the studs. I run the first electrical line to the outside, and with the in and out method we go from the first outlet to the next outlet through the studs, and from the second to the third, and so on and so forth. For this build, I'm using a 12-2 Romex. 12-2 are rated for 20 amps, and also you can tell it's a 12-2 by the color yellow of the cable. From the third outlet, I run up and over the rafters and down to the switch. And don't forget to pick up the last electrical outlet. At this point, every electrical box should have got a cable, which means it should have power in and out. Now it's time to go from the switches to the lights. I run my first line to the right side exterior light, and from that exterior light, I jump it over to the left side. And for the recess or pocket lights, I go from the switch to the first one, and then from the first, I go to the second, third, and fourth recess light. To secure the wires to the stud, I use an insulated staple. They are rated to be used on this type of projects and can be found pretty much in any hardware store. Now we go back to the first outlet and we start cutting in the wires. The first thing you do is remove the outside yellow jacket. If you have a wire stripper, this comes handy. If you don't have a wire stripper, you can use a knife. You will need to add a staple within 12 inches of entering an electrical box. It's okay to combine 2 cables with one staple, but no more than 2. Then I separate out the wire collars. I take the 2 ground wires and I twist them together all the way. If you have a green wire nut, this is the time to install it. If you don't, you can grab an extra piece of copper wire and twist it over the ground wires, and then use a regular wire nut and twist that in. I tuck in the ground wire all the way on the back of the box. Then I grab all the wires together and with the palm of my hand I wrap it around and I measure with my thumb. I cut the excess wires and that should be sufficient wires for you to install an outlet later on. And to tuck it in, I push it down first and then I roll all the wires in. This method makes it easier for you to install the outlet later. For me, I had 4 outlets, so I did this 4 other times. Then I move to the switch box. This has a lot more wires. It may look complicated at first, but it's not. I start by cutting all the wires into the box. Then I work backwards, stapling the cables onto the stud. Remember, each staple can hold up to 2 cables. I had 3 cables on this wall, so I had to put 2 staples side by side. When you do this, try to get them as center of the wall as possible. If you remove the yellow jacket before inserting the cables into the box, that is great. If not, you can always do it at any time. The goal is that for the yellow jacket not to exceed 1/4 of an inch inside the box. Whenever I'm working with a lot of wires like this, I always start with the ground wires. You reduce a lot of the work if you take them out of the way. Twist all of them together, and then for each device, you're gonna need 1 pigtail. I have 2 switches here, so I take 2 extra pigtails and I twist it to existing ground wires. Then I take all the neutrals, which are the white wires, twist them all together. The trick is that you keep them all parallel except one. One of them you keep it at a 45-degree angle, and then you twist them all together. Now you are left with the black wires. Find your power in and power out. Those are your in and outs. You add 2 pigtails to these wires, also known as leads. Twist them all together and tuck them in. Each of the pigtails will feed power to each of the switch. So you need to take one of the pigtails and combine it to one of the lights, which are going to be switched later. Also, when doing that, you take one of the ground wires and add to the set. Your set should have a ground wire, a pigtail from the power coming in, and the wire that goes to the light. Before moving outside, take one last look at the work. Make sure you have in and out on every outlet. Make sure all the cables are properly secure with staples, and that you have cut in all the boxes and tucked the wires in so they don't get damaged during sheetrock installation. On the outside, I'm using a single gang exterior box. I install a Romex connector onto the box and slide the cable inside the box. I did not have any exterior screws or galvanized screws for me at this time, so I used sheetrock screws. I do not recommend using sheetrock screws. As soon as I get some new screws, I'll replace these out. I'm using the end of a 12 gauge extension cable to attach to the shed. They do make outlets with the extension cord cable end already in them. However, it's very difficult to find unless you purchase from an electrical store or online. And also, I want to show an alternative if you don't find the outlet. You strip about 8 inches of the extension cord and expose the wires. And using a cord grip connector, I install that onto the extension cord. Then screwing the connector into the electrical box and tying it down with the channel locks. It's now time to install the GFCI. First, I remove the ground nut that's in the back. I make a loop on the solid ground wire so I can loop it around the ground screw. I then screw the ground screw back into the electrical box, holding the ground wire in place. I twist the extension cord ground wire with the solid ground wire and added a pigtail for my GFCI. Then you cut the wires and strip off the ends. And also behind the GFCI, you're gonna find a line and load indicators. Line is the wire that's coming into the shed, so that is the extension cord. And load is the shed itself, so that'll be the solid wires going inside the shed. You insert them into the GFCI and tighten them down one at a time. And you finish it by installing the cover right over the GFCI. And eventually you have a plug-in shed that you can run an extension cord and plug it in. If you like, you can buy one of these covers that will protect the extension cord from the weather. Now this is a pretty basic electrical setup for an office shed. But if you want to have your shed running off the grid using solar panels, Scott has a video for you right here. And if you want to check out everything from beginning to end, how we transform this shed into a backyard office, it's right here. And remember, if you plan to build your own shed, check out everydayshed.com or the description. We're going to have plans, videos, and materials list that makes it easy when it's your time to build your own shed. I hope you learned something from this video, and I'll see you in the next one. Thanks for watching. Bye.